Welcome back dear kids. Today we are dealing with exercise 1.3. In the last class already we have studied how to convert decimal expansion in P by Q form. Okay, now we will move to the exercise 1.3. Some of the rational numbers they have given here, then we have to convert that one into decimal expansions here. So first one is 36 by 100, that is 0.36. Second one is 1 by 11, that is 0.0909, it will continue. So we can write this one as 0.09 bar here. Next, third one, 4 integer 1 by 8. So first convert this one into improper. 4 8s are 32 plus 1, 33 by 8. If I am going to divide 33 by 8 here, then 8 4s are 32. Then 1 remains, point will give you 0 here, it will become 10. 8 1s are 8, then 2 remains. 20, 8 2s are 16, 4 remains, then 8 5s are 40. Finally, it is going to, remainder is 0. Then come to the fourth one, 3 by 13 here. So divide this one here, 3 by 13, you will get 0.230769. These 6 digits are going to repeat continuously. So we will write 0.23076 bar. So now come to here, 2 by 11. Here we will get 0.18181818 and so on. So that is why we will be writing 0.18 bar here. So 329 divided by 400. So we will make a simplify here. 329 divided by 4 into 100. We are going to write it. The next step we will cancel 4 ones and 482.25 here. We are going to cancel. Why we are going to write this one here? If there is a denominator is 0, then very easily we can adjust the point here. These two zeros, this decimal point will shift to back side 0.8225. Then very simple, group that one, terminating decimal expansion and recurring decimal expansion. First or third, sixth are terminating decimal expansions, and second, fourth and fifth. These three are non-terminating or recurring decimal expansions. Come to the question number 2 here. Already we know 1 by 7 is equal to 0.142857. These digits are going to repeat or recurring decimal expansion. Then they have asked what is the value of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. It is a very simple one. 2 by 7 I will write it as 2 into 1 by 7 because 1 by 7 value is already we know. So 2 into this decimal fraction, decimal expansion we have to multiply. 2 7s are 14 here, carry 1. 2 5s are 10 plus 1, 11 here. Then 2 8s are 16 plus 1, 17, carry 1. 2 2s are 4 plus 1, 5 here. Then 2 4s are 8, 2 1s are 2 here. So 2 by 7 is equal to 0.285714. So magically all these digits are same here, but the places have been changed here. So 3 by 7, 3 into this one. Again multiply this 3 to this one, you will get 428571. So on the multiplication of 3, 4, 5, 6, all these digits will be same here, but the places of that, those digits are going to change. Simple one problem. Pause the video and write it down. We will come to the question number 3 here. The first one, 0.6 bar. We have to convert this one into P by Q form. Very simple. X is equal to 0.6 bar. First we are going to consider. Then only one digit is repeating here, so I will multiply with 10 here. 10 into x is equal to 0.6 bar into 10. So it is 10x here. After multiplication with the 10, one digit of the 6 will come before the decimal, 6.6 bar. Then continuously these are 6 are repeating here. So I will subtract these non-terminating recurring factor here. So I will select x here, so that 0.6 is here. X is equal to 0.6. These two continuously repeating factors are going to cancel each other. Then 6 is here, 10 minus 1 is 9, 9x. So x is equal to 6 by 9, or cancel this one, 3 2s are 3 3s are 2 by 3. So final answer is 0.6 bar is equal to 2 by 3. It is in the form of P by Q. Same here, second one 0.47 bar. First there is a one digit 4 which is not repeating, only the digit 7 is repeating continuously. So for that reason, first I will take this 4 before the decimal point. So I will multiply with the 10 here, 10x, and into 10 it will be 4 is before the decimal, 4.7 bar. So now we have taken all the repeating factors after this decimal. So from this point our problem will begin. So only one digit is repeating, multiply with the 10 here, 10 tens are 100, then 4.7 bar into 10 will be 47.71. 1 7 is before the decimal. So 0.7 bar I want to cancel, so I will select this 10x here, not this one. I will select this here, so that I will cancel these two, 7 bar and 7 bar. 47 minus 4 is 43, 10 minus 100 minus 10 is 90. So x is equal to 43 by 90. Final answer is 0.47 bar is equal to 43 by 90. So come to the third one here. It is also very simple one here. 0.001 bar. These three digits are repeating continuously. If the three digits are repeating, so I have to multiply with 1000 here. So 1000 into x, 0.001 into 1000. So it is 1000x. So if I am going to multiply with 1000 here, then this one will come before the three digits. Or in other words, these three digits will come before the decimal point. Whether you are going to write 001 or simply 1, both will be same. That is why I am going to write 1.001 bar. So subtract the x here. These two repeating factor will be cancelled out. 1 is here. 1000 minus 1 is 999. Finally, 0.001 is equal to 1 divided by 999. Okay. Let's kids come to the fourth problem here. Fourth problem is convert 0.9999 in the p by q form and see what is the answer. Okay, it's a very simple one. First I will write this x is equal to 0.9 bar. 9 bar because 9 are continuous. These are repeating continuously. Recurring decimal expansion. Only one digit is repeating, so I will multiply with the 10 here. 10 into x, 0.9 bar into 10 here. So 10x, 10 into x is 10x. Here one digit will come before the decimal, 9.9 bar. So I will subtract this x here. X is equal to 0.9 bar. 9 bar both will be cancelled out. Then 9 will be here. 10 minus 1 is also 9. So x is 9 by 9 and it is equal to 1. How this 0.999 has finally become 1 here. So that is a beautiful one here. On this number line, 0 will be here and 1 is here. Then 0.9 is here. But 0.9 is here, but how this 0.999 finally came out to be 1 here. Okay. See this one, this is a very beautiful. So again, here if I am going to select this 0.9 here, and here it is 1, or take this one as 1.0, then middle is 0.95, or in a very simple manner, write down 10 here, 10, then it is very simple here. 90 is here and 100 is here. What will be the middle one here? 95. And where is the 99? 99 will come here. 0.99 it is. So 0.9 is here. If I am going to take this 0.9 and 1, I am going to zoom that one, and 0.999 will here. So 0.9 and 0.99. So this point is reaching nearest to 1 here. So again, if I am going to zoom these two, 0.99 and 1 again here. So let us see what happens here. 0.99 and here it is 1 again. So if I am going to make 1 0 here, 990 and 3 zeros, I am going to write. So for our convenience, I am going to write this 100 here. It is actual value is 1 only, 1.000 we have written. Then here is 990, 991, 992, 993 and so on. Here it will be 999. Actually it is 0.999. See here, from 0 to 1 only we have made 10 part and 0.9 is here. Then if you are going to make a 0 to 1 100 parts, then 99 is nearest to that one, nearest to this 1.00. Next, from 0 to 1, if you have made 1000 different parts, so 0.999, it is still nearest to that one. So in this way, how much more digits you are going to take? 9999, you are reaching to nearest to 1. So if you are going to consider the infinite number of 9 here, then it is very nearest to 1. Almost it is 1 only. So that is the answer. Here 0.9 is 1. But it is not going to understandable. Okay, I will tell you one beautiful story of this one. There is a one saying, what do you think today, tomorrow you will be. ಅಂದ್ರೆ ಏನಪ್ಪ ಈಗ ಅಂದ್ರೆ ಇವತ್ತು ನಾವು ಏನು ವಿಚಾರ ಮಾಡ್ತೀವಿ, ನಾಳೆ ನಾವು ಅದೇ ಇರ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಅದಕ್ಕಾಗಿ ಒಂದು ಸ್ವಲ್ಪ ಚಲೋ ವಿಚಾರ ಮಾಡ್ತೀವಿ. ಇವತ್ತು ನೀವು ಏನೇನು ವಿಚಾರ ಮಾಡಿರ್ತೀರಿ, ನಾಳೆ ಅದೇ ಇರ್ತೀರಿ ಅನ್ನುವಂಥ ಒಂದು ಹೇಳಿಕೆ ಇದೆ. ಅಗದಿ ಸಿಂಪಲ್ ಆಗಿ ಎಷ್ಟೋ ಮಂದಿ ಭಕ್ತರಾಗಿದ್ರು. ಆ ಭಕ್ತರು ದೇವರನ್ನ ಭಕ್ತಿ ಮಾಡ್ತಾ 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 ಇಷ್ಟು ಭಕ್ತಿ ಮಾಡಿದ್ರು ಅಂತಂದ್ರೆ ಆ ಭಕ್ತ ಮತ್ತು ದೇವರ ಇಬ್ಬರೊಳಗೆ ನಡ್ಬೇಕು ವ್ಯತ್ಯಾಸನೇ ಉಳಿದಿಲ್ಲ. ಆ ಭಕ್ತ ಏನಾದ್ರೆ ಲಾಸ್ಟಿಗೆ ದೇವರೊಳಗೆ ಒಂದಾಗಿಬಿಟ್ಟ. ಬಹಳ ಸತಿ ನಾವು ಪಿಕ್ಚರ್ ಒಳಗೆ ಅಲ್ಲಿ ನೋಡಿರ್ತೀವಿ, ಅಥವಾ ನಮ್ಮ ಅಜ್ಜಿ ಕಡೆ ನಮ್ಮ ತಾಯಿ ಕಡೆ ತಂದೆ ಕಡೆ ಹಿಂಗೆ ಕತಿ ಹೇಳಿದ್ರು ನಾವು ಕೇಳಿರ್ತೀವಿ. ಆ ಭಕ್ತ ಇದ್ದಾಗ ದೇವ್ರ ಕಡೆ ಹೆಂಗ್ ಒಂದಾದ, ಹಂಗೆ ಹೆಂಗ್ ಭಕ್ತಿ ಮಾಡಿದ ಅಂತ ಅನ್ನೋದನ್ನ ಇಲ್ಲೇ ನಮ್ದಿದು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅನ್ನು ಹೇಳ್ತದೆ ನೋಡಿ. ಈ 0.9999 ಇವು ಎಷ್ಟು 99 ನಾವು ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ ಆಲ್ಮೋಸ್ಟ್ ಲಾಸ್ಟಿಗೆ ಇದು ಒಂದಾಗಿಬಿಡ್ತದ. ಈಗ ನಾವೇನು ಹೇಳಿದಿಲ್ಲ, ಇವು 999 ಏನಪ್ಪ, ಇದು ಭಕ್ತಿ. ಎಷ್ಟವ ಭಕ್ತಿ ಮಾಡ್ತಾನಂದ್ರೆ ಆ ದೇವರ ಒಳಗೆ ಒಂದಾಗಿಬಿಡ್ತಾನ. ದೇವ ಮತ್ತು ಭಕ್ತ ಇಬ್ಬರು ಬೇರೆ ಬೇರೆ ಅನ್ಸಂಗಿ ಇಲ್ಲ, ಇಬ್ರು ಒಂದ. ಸೊ ಇಂಥ ಕಥೆಯನ್ನ ಅಥವಾ ಈ ಎಲ್ಲ ಮಹತ್ವವನ್ನು 0.99 ಹೇಳ್ತಾರೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. Come to the fifth problem. It is very easy. We have to write a decimal expansion of 1/17. So start dividing this one, 17 and 1 here. So first we will take the 0. 17 zeros are 0. Then 1 minus 0 is 1. Give the decimal point here. It will become 10 here. But 17 is greater than 10. So you will take a 0 here. Then it is 100. Then 17 5s are 85. Subtract this one. We will get the 15 and 0. This decimal is going to give the 0 here. Then it is 150. 17 8s are 136. So 150 minus 136 is 14. Then decimal point is going to give the 0 here. Again 17 8s are 136. 4 remains, it is going to 40. Then 17 2s are 34. It is going to be 6, 16. So continuously go on division. Then after this one here, at the end of the page, come and write down here again. Write down the 60 here. Then 17 3s are 51. So like this one. Continuously do the division here. Then finally we are getting these much of the digits here. And after this, same digits are going to repeat. So how many digits are there? Maybe these are 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Totally 16 digits are repeating here. So 1/17 is this much decimal expansion. Okay. Come to the sixth question here. What is the sixth question here? Select some of the rational numbers which are in the form of p by q. And what is the property of the q? That means what should be the denominator so that it should have terminating decimal expansion. It should not be recurring decimal or repeating. It should have terminating decimal expansion. So first we will see the some of the example here. 1/2, that is 0.5, terminating 1. 1/5, it is 0.2, it is also terminating here. See 1/10, yes, it is terminating. 1/4 or 1/25 or 1/40. All of these are terminating decimal expansion. Very simple here. If it is a denominator is a 2 or 2 power. 2 power means 1/2 is 0.5, 1/4 is also 0.25. Then 2 raised to, this is 2 raised to 2. Then 2 raised to 3, it is 1/8. 1/8 is what is the decimal expansion? It is 0.125. It is also terminating. That means first we should have 2 power n. N is a natural number, any natural number. Whether it is a 2 or 2 power, then it is going to have terminating decimal expansion. Another case, whether it is a 5 or 5 5s are 25, or whether it is 125, that means 5 raised to n. So first case we should have 2 or 2 powers, and second case 5 powers. Next here 10 is also there, and this one 40 means we are going to divide this one into 8 5s are 8 into 5. 8 is what here? 8 is 2 cube, that is 2 raised to 3 and 5 raised to 1 here. 2 raised to 3 is 8, 8 5s are 40. That means first case it must be 2 raised to n or 5 raised to n or 2 raised to n into 5 raised to n. If these three are in the form of cube, then that is going to have terminating decimal expansion. Very simple. Denominator must be in the 2 power or 5 power or 2 power and multiplied with 5 power. This 10 we are going to take it as 2 into 5. So 2 raised to 1 and 5 raised to 1. Like this. Write any 3 examples of non-terminating and non-recurring numbers. That means irrational number you have to write here. Very simple. 3.16, 17, 18, 19, 21, 22, whatever the digits came to in your mind, write down all these here. Or any 2 examples of your own choice. Write down. there should not be any repetition, or there should not be any termination. So non-terminating and non-recurring. Then question number 8 here, very simple. Write the three rational numbers between irrational numbers between 5 by 7 and 9 by 11. So first we are going to convert this 5 by 7 into decimal. So it is 7 sevens are 49 is there, 1 is going to remain and it is going to continue. But we want only 0.7, and here 9 by 11, 11 divided by, so 9 divided by 11, it is going to be, after the decimal it will become 90 here, then 11 8s are 88, then still the digits are going to continue. We are not going to consider that one. In a very simple, whatever the three numbers we are going to write, that must be in between 0.7 and 0.8. That I have to remember. So for that reason we have taken 0.7 and 0.8 only. So now here 0.7126, 789, whatever the digits came to your mind, you have to write. So 0.712, 0.79. Up to this much only you are going to write in between these two. Next digits of your own choice. Write down anything. So question number 10, last one is very simple. Simply you have to group the two here, rational and irrational. So rational number, this one 225, square root of 225 is nothing but 50. It is a rational number, or 15 by 1 we can have. Next 0.3796, it is a terminating decimal exponential, so it is a rational number. Next one 0.478, 478, 478, it is continuously repeating here, so recurring factor will also come in rationals only. Then irrational, square root of 23, and next 1.10, 100, 100, 100, 140, so on. So it is the end of your exercise 1.3. So we'll meet you in the next class. Have a nice day.